Hi everyone, I'm back to show you the perfect square expansion. Now, what is the perfect square expansion? We're going to look at a bracket like a plus b squared, and we're going to see if we can find a generalized rule how to expand these brackets. Before we look at anything in general, let's have a look at an example. What about x plus 3 squared? I'm going to draw a multiplication grid, and I'm asking you to do the same so that we can go along working with our algebra tiles. I might even need a little bit more space here. Let's see. And this is a multiplication grid, so the multiplication sign goes here on the top. Now, probably you're asking, I only have one bracket here. Before we always had two. So what do I put in my first column and in my first row up here? Well, I'm gonna show you a small trick before we do, because actually I think you know that x plus 3 to the power of 2 means that we're multiplying x plus 3 times x plus 3. Now you've got your two brackets, and I'm going to ask you to pause the video right now to try to solve this by yourself before you're coming back to check if you were right. So I'm assuming that you tried and that you're back to check your answer. So my first bracket here says x plus 3. So that's what goes in that first row here. X plus 3. So we have here x plus 1, 2, 3 units. And the same thing goes here in our first row. 1, 2, 3 units. There we go. And I'm sure you have tried to multiply these two. So please note, you have the same here as here. X times x gives you x squared. X times 1 gives you x. X times 1 gives you x. X times 1 gives you another x. 1 times x gives you x. 1 times 1 gives you 1. 1 times 1 gives you another unit. And 1 times 1 gives you another one. You have 2 more rows that are exactly like this. So there we are with our product. And when you look at it, you can also see, opposed to before, we always had in our solutions, we usually had a rectangle. Here, we now have a perfect square, hence perfect square expansion. So let's simplify, or let's write this down actually. What do we get? We have here x squared. We have here 1, 2, 3, 4, 5, 6x. And we have here 1, 2, 3, 1, 2, 3. So this here gives you 9 units. You can also count them up to get to 9 units. And this is the answer to this question. There we go. You could have also used the FOIL method to find this out. I'm not going to show you how now. We have practiced this already. I am going to have a look at the more general form with you right now. And I am going to use 2 different colors to represent A and B. So our A is going to be that green tile that we usually use. And our B is going to be that pink tile. Okay. And I'm asking you again now, try to pause the video and try this on your own. It's a bit tricky, but you can still give it a go. And when you're back, I'm going to show you how to work this out. If you don't feel comfortable, stay on and watch how to do this. So, in our first row here goes 1A and 1B. And in our second row here also goes 1A and 1B. Now, we're going to multiply. A times A gives us, and this is now going to be our A squared. Then we have here A times B. Now, what does A times B give us? A times B gives us a rectangle let's see. It gives us a rectangle that has here a length of A and a width of B, right? This here, don't have space. This is our B, right? So what we can do is we can give this rectangle a label, because this rectangle is now AB. Why AB? Because it is A times B, and A times B, length times width, gives us AB. So this is AB. Then here again we have B times A, and that's exactly the same thing. We have another rectangle with a width of A and length of B. So let's label this again. This is another AB. It's a rectangle with the length of B and the width of A. And if we want to calculate the area, that's A times B, giving us AB. And finally, we have our B times B, giving us a B square. So to make this consistent. Let's label the other two as well. So we had here a squared, that was a times a, giving us a squared. B times b, giving us b squared. So what have we got here in that generalized form? Our result gives us a squared plus ab plus ab. How can we simplify that? By collecting like terms. ab plus ab gives us 2ab plus b squared. And I can tell you will need it again and again and again and again. So I would suggest that you really learn to work with this now, because you will need this in DP2 as much as you will need it all the way up to DP2. So it's really good to work on this and know how to use it. Example, we have 2x minus 3 squared. Pause the video, try this with your algebra tiles, and then come back to see if you were right. I'm assuming that you have tried and that you're back to see if you're correct. I'm going to start with the algebra tiles as I always do. So we have here 2x minus 3. I am not going to even bother to put this into two brackets because I know that the same term, the same expression goes in the row here, in the column here, and in the row here. So we have 2x and negative 3 units. 1, 2, 3. 1, 2, 3 units. And another 2x go in that first row here, and another negative 3 units. So let's get started. X times x gives us x squared. X times x, x squared. X times negative 1. So remember, x times 1 gave us x, but positive times negative gives us a negative. So we need to flip that over. Just doesn't like it. There we go. X times negative x, same thing, gives us a negative x here. X times negative 1, sorry, I think I said x here. X times negative 1 gives us a negative x. X times negative 1 gives us another negative x. So for our second row, it's exactly the same thing. Next row, negative 1 times x gives us negative x. Negative 1 times positive, did I just say negative x here? It's negative 1 times x, right? Negative 1 times positive x is a negative x. Then we come to our units. Negative 1 times negative 1. So 1 times 1 is 1. Negative times negative is positive. So we have a positive 1 here. Negative 1 times negative 1 gives us a positive 1. Negative 1 times negative 1 gives us a positive 1. Same thing for the next two rows. So there we are. We're done with that, and all we need to do, you can see here, it's again a perfect square. All we need to do is we need to collect our like terms. So we have here our units, our x's, and our x squares. So how many of each do we have? Let's see. We have 1, 2, 3, 4x squared. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Careful here. 12 negative x. So we have negative 12x here. Plus 3 by 3 is 9. So that's the solution to expanding these brackets. And now we're going to try and use our law that we have produced here and see if we got the same thing. So our a from that bracket here is the first term in that bracket, and the b is the second term in the bracket. So our a is 2x, our b is, careful here, negative 3. You need to take the right one here, whether it's positive or negative. So let's see. Our law says that a plus b squared is equal to a squared plus 2ab plus b squared. Now let's have a look. The a is the first term in our bracket. So that's the 2x. So we need to square that. So 2x squared plus 2 times a times b. 2 times a is the first term. So that's 2x. A is 2x. B is the second term. So that's a negative 3. B is negative 3. So we're done here. And finally, we have that b squared. The b is the second term in the bracket. Negative 3. B is negative 3. So negative 3 squared. Now let's have a look how we can simplify that. You learned in one of the last chapters, index needs to be applied to both terms in the bracket. 2 squared is the same as 2 times 2, giving you 4. X squared gives you x squared. Plus. Is it plus? No. Plus times minus gives us a minus. Now let's calculate 2 times 2 times 3, giving us 12. And we mustn't forget that we still have an x here. And then plus, or is it minus? Because actually it's plus and minus. Think about that for a second. It is going to be plus, and I tell you why. And this is something that you really need to remember very, very well. Negative 3 to the power of 2 means, I'm going to write this out here actually. Negative 3 to the power of 2 is the same as negative 3 times negative 3. Negative times negative is positive. So negative 3 times negative 3 gives you a positive 9. If you put in your calculator the same thing without the bracket, what the calculator will do is it will calculate negative 3 times 3. And negative 3 times 3. 3 times 3 is 9. Sorry. And you still have that negative in front. So please be very careful when you have negative numbers. It's safe to put them in brackets so that it doesn't give you the wrong result with the calculator and that you don't get mistaken. You need to multiply negative 3 times negative 3. It's not negative 3 squared, which would give you 3 times 3 negative. Yeah? Right. So we have here final answer plus 9. And we can see that this is exactly the same as we got with our algebra tiles in that first line here. As I said, this law of the perfect square expansion, you will need that again and again and again and again. So please practice that. Use your algebra tiles. They're great. They're brilliant to visualize that for you and to get a feeling of how to deal with algebraic expressions. That's it for now. Thank you for watching, and I'll see you for the next video.